Let me guess. You are learning SQL, and probably everybody keeps throwing window functions, recursive CTs, and probably interview brain teasers at you. But I'm telling you, when you get to work, you're probably writing about 7 SQL queries over and over and probably forever. So today, I'm breaking down the only SQL queries that data analysts actually use on the job. I'm talking about real world SQL, like the workplace SQL. So if you're an aspiring data analyst or a junior data analyst trying to feel less lost, or probably a career switcher wondering if SQL ever gets easier, this video is for you. So let's dive into the demo with the most powerful SQL combo of all time. For this demo, we are going to use SQL Server Enterprise Developer Edition 2025, and we are also going to use AdventureWorks 2025. And for Management Studio, we are using the latest version, which is Management Studio 22, the one that comes with Copilot and Git integration. This SSMS is pretty neat and nice to use. So if you don't have all the tools that I just mentioned already installed, I do have a video on how to install SQL Server 2019. Now, this version that I have now is 2025, but the installation process is pretty much similar or probably the same. So watch that video. I'll put a link to that video in the description below. I also linked the video at the top left or top right of this video. So watch the video, install the tools, and let's dive into some demos. So we're going to start by clicking on New Query to get a query canvas. I expect that you make a connection to the database. You typically click here and you select Database Engine, and then you hit Connect, and there you have it. So we're going to start with the most powerful SQL combo of all times, and that will be select and where. So before I execute this query, let me just say a few things. Every data analysis starts here. Every dashboard starts here. Every report typically starts here. So whenever you get those ping in your Slack or your Teams or wherever, and it says, hey, can you quickly pull that data? Can you quickly pull that data? You are 80% using something like this. The select is the data fields or the columns that has to be seen on the report. And the where clause is essentially the filters. In this case, I'm trying to pull all the data that had an order greater than or equal to a specific date with a dollar value. So this here is the business logic, right? So the filters becomes your business logic. And this query alone can do about 70 to 80% of the requests that comes to a data analyst. And this highlighted section, the where clause, that's where the bugs lives. All the bugs, it starts from the bad where clause. They live right here. So whenever you're trying to filter the data, you just have to be very meticulous and particular in terms of, the requests that you have. All right. So this is it. Select specific fields and throw in some business logic and output that data. Next is joins. I'm going to say something very controversial here and I'm going to say this from experience. Throughout the years and all the things that I've done with data, the most critical joins you're going to typically write a query with on the job are two, inner join and left join. Essentially, inner join is saying that show me all the matching records, and the left join is saying don't you dare drop my data. For this query I have here, right? I have how many tables? 1, 2, and 3. And I'm saying that I want to see the matching records in all the 3 tables, okay? So this query here is just essentially showing the matching data. But in the second query, I have a left join, and I'm saying that this is my main table. I want to see everything that exists in this table. Don't drop anything. But also, if there are matching records in the customers and the persons table, I want to see them as well. So I'll say if you master inner join and left join, congratulations, because you can already do most of the requests that comes to you as a data analyst. The next one that I want to talk about is group by and aggregations. I say this is where analysts typically earn their paycheck because this is the one that you use for KPIs, monthly reports, I'll say executive decks, because they don't want the rows, they want the totals, they want the trend, and they want the summaries. So whenever you pull a query together like this, that's exactly what you're trying to accomplish. So here I said group by, and I also mentioned aggregations. Now these, they go together. anytime you are pulling data from SQL Server or SQL, and then you introduce some form of aggregated function. In this case, I'm doing sum. You could have done max. I could have done min. Min, and I could have done average, right? AVG, sorry, right? But in this case, I want to see the total, the sum. So I'm saying that I want to sum the data across certain data points. I'm summing this data across the order year and then the order month. So essentially, the output of this data is going to render three things: the year that was ordered, the month that was ordered, and the total sum of the amount that was ordered in that month. And that is what this group by is helping me do. So I'm going to run this and you see the output. So essentially in 2023, in the month of September, there was 38,000. Wait, what is that? I can't read it. There was 3.8 million total sales in that month. All right. So that is what the group by helps you to do. And one thing you have to understand is you can group by as many columns as you can, but if you group by too many columns, it's going to lead to, I would say, fake precision, right? So it's better to group by fewer columns as possible. If you're grouping by about like 10 or 11 columns, or how many columns, you're probably lying to yourself. Okay. Now, next is case when. We are going to talk about case when. Let me paste my query here. I'd say case is where SQL stops being technical and start being human. Okay. When I say human, it's just essentially translating the business rules into the data. And it typically makes your dashboard even smarter. So in this case, I'm trying to say, I want to see the order ID, the order date, and then the total due. However, I still want to have something I call the order value tier. And in this case, I'm grouping them by the total due. So essentially, I'm saying anything that is greater than or equal to 5,000, I'm calling them my high. And anything from 4,999 up to 1,000, I'm calling them my mid. And everything else that do not meet these two criteria, we would call them low, right? So here I'm rather turning my messy data into segments or labels, or I would say decisions. And yes, this can replace about I don't know how many Excel formulas it can replace. I'm just saying. All right. Assuming you have this presented on your dashboard like a Power BI or let's say a Tableau, once you see this field, I mean, it would have some legend to explain what it's doing, but it just helps you to visualize things pretty quickly. The fifth one that I'm going to talk about is order by and top or limit. So because I'm using SQL Server, I'm going to be using the function top. But if your database was different than SQL Server, you might be using limit. So this one is simply one of those queries that executive loves. I'm not saying they love queries because they write queries, but it gives them the things they want to see. It is the thing that would help you understand your customers in segments, the tough performing customers, the tough performing product, as well as the poor performing ones. I'm going to run this query. So what this query is doing is essentially saying that given the sales orders table, I want to see all the products that match a record in the sales order table. And I want to see the product that has the top revenue. So I'm doing the sum, which is an aggregate function, and it always goes with the group by. And then the most critical part is the order by, descending. You see, I'm trying to understand my top 10 products. I have an order that I'm doing. I'm saying that order the records by the revenue, descending order. That means the highest to the bottom. And I only want to see only 10 records to be rendered out here in my output. So if you see this query gave us how many? 31,000 output, okay? But here I'm limiting my number of records that I will see, the number of rows. I said I want to see only 10, but I only want to see the top 10 per the revenue. And that is what this is doing. So when I say executives love this query, this is essentially what I mean. It tells you your top 10 performing products or your customers, whatever. Essentially, it highlights your biggest problems and actually tells you what you should be panicking about and what you should be probably producing more. That's it for order by and top. What I have next on my list is subqueries. These are criminally underrated because they are readable, they are logical. I mean, they are easy to debug. You see, when we talk about subqueries, this inner query here is a query on its own that you can execute. If I took the distinct out, for example, I'm getting a whole list of how many? 594. All that this query is doing is it wants to see every record in this table where the order quantity was greater than a certain number. And if I run this, you see I have duplicate outputs. That is why I put in the distinct so that I can see only the distinct. So this 594 is going to go down very drastically. We are down to 51. Okay, so now I have 51 distinct products where the order quantity was greater than 15. And in this top query here, this is the main query. But I'm saying I want to see the product ID and the product name where the criteria in selecting this product meets the inner query here, which is the subquery. All right. So when I run this here, you'd see that all the product or product names you see here, they some way or the other had a quantity greater than 15. Okay. And this time I'm ordering by the name descending. Of course, this is alphabetical order. So if I removed this here, descending, if I remove this, I think the names that started with A or probably B would come up at first. Here, you see here? I would take a very clean subquery than any monster join. And finally, this leads me to my last query or last thing I want to demo today. Window functions. Window functions, I'd say they are powerful but optional because you don't typically use them on a daily basis. But when you do need them, you really do need them. In this example, I'm trying to order my customers by sales. Okay. Now over here, I have top 50 customers and I have customer ID, customer sales, and then I'm doing the window function right here. Okay. And then I'm joining two tables, order header and customer. And of course, when you join, you need some joining keys to join with. And I'm doing the group by. Anytime you introduce an aggregate function and you have an extra data point that is not in an aggregate function, you have to introduce a group by. So there it is. And then I'm doing something very important here. As I explained, the descending order is important. I'm trying to see my top 50 customers by sales. However, in this example, I want to assign some numeric ranking to them. So that is essentially what I've done here. And I'm using something called dense rank. Okay, that's a dense rank that I'm using for this window function. I could have simply used rank. Okay, now that I've mentioned it, let me just explain it. So in this example, I said I'm using dense rank. I'm going to run this query here and I'll explain what the dense rank does. So here it's showing that customer 29818 is my top customer because that customer has the highest sales. I can't read the number. Let me just put it right here. That customer made about $989,000 in sales. Okay. Now, when I said I was going to explain the dense rank, let's say you have an ID field. Okay. You have 1, 2, 3, 4, 5. And then let's talk about rank and probably tab and let's talk about dense rank. Okay, I'll take that. So let's say customer 1 and 2 had the same number of sales, amount of sales. That means there is a tie. Okay, so in this case, there is 1 and 1. Now we have customer 3, that is not part of the tie, but in ranking, you get a number 3. Whereas if you use the dense rank, there would be the there will be the tie, but then the next number is not going to be skipped. You're going to have the sequential order. Okay, so in this example, I just want to see who is my number 1 and who is my number 2. And my number 1s can have a tie, and that's okay, but still, I want to see the second customer, not the third, right? That's why I'm using the dense rank in this particular example. All right. Again, you can use window functions to also do what we call the running total. Okay, so there are days that you want a report to actually show you your sales over time. Okay, so in this example, there was sales that was made on a particular day, and then there was sales that was made on the next day. So we've added the sales from day 1 and day 2, and now we see it. And then of course we have the sales that was made from day 1 to day 4, and that's the dollars here. All right, so that's the running total here. And like I said, window functions, these are the ones that will separate you from I know SQL to I know how to analyze data, I would say. So they're very powerful and optional. And this leads me to the end of my demo today. Let's clear this up. You probably will use recursive CTEs, insanely nested SQL queries, or let's say SQL queries that look like a PhD thesis. So if your SQL queries need a user manual, you're probably over engineering. If you master these queries, you can do about 80% to 90% of data analyst jobs. Everything else is just variations. So if this saved you time, hit like and subscribe for real-world analytics content. And also comment below which SQL queries you use most at your current workplace or at your current job. And if someone told you SQL had to be hard, they lied. See you in my next video.